right, so the second topic of today is bootstrapping. Let's get into what that means. Right, and I choose to show you how to do bootstrapping by a very concrete example. That's then you can do the generalization yourself. And there are all kinds of variations of bootstrapping. You can read a lot about that on the internet, different places. But at the end of the day, it's the bread and butter of bootstrapping is what you can find in this one slide using this one example, and that's what I want you to do for the rest of this course. Then you're welcome to look into all those different variations of bootstrapping later on. So this is kind of the starting point. This is the basics of bootstrapping that we're going to talk about today. Right. So let's assume that you have 120 months of return data. Right. So 120 months of data. That's well, it's 10 years. Right. So you have data on the last 10 years on, let's say, 8 different stocks or ETFs or what have we. Right. Index funds. So 10 years of data, and what you want to do is that you want to generate 250 scenarios. Now here comes the first problem. If you didn't know what bootstrapping was, if I gave you this problem last week, right? You have 120 months of data, and you want to generate 250 scenarios, right? And then let's say in case 1, I want to ask you, I want you to generate 250 scenarios of the length 1 month, right? So now, in order to do that, if you wanted to do that, you have to look into this 120 months and either do like what we did last week. You say, well, I mean, I can give you these 120 months back again and just say, well, these are the 120 monthly scenarios that we are looking at 1 month ahead. And that wouldn't be, such a bad idea in a way. But that kind of limits you to that one option only, right? So you can only generate 120 scenarios. If I want you to do 250 scenarios, could you do that? I mean, could you do that without repeating some of the months? No, you can't, right? So even if you use all the 120 months once, and then you have to probably use the 120 months one more time, and then some of the scenarios you have to use for the third time, right? So you will get some repetitions. So your scenarios are not really much. The 250 scenarios wouldn't be much worth if you were going to look only 1 month ahead. Another way of looking into this, when we talk about bootstrapping, is that if I tell you in how many ways can you pick 1 month out of 120 months. So you probably remember you had a formula like that. Either you get it somewhere at your secondary school studies, or maybe at the first mathematical course in combinatorics at university, where you're familiar with that notation. That reads something like it's a binomial coefficient, isn't it? And it reads 120 choose 1. So that means in how many ways you can choose 1 out of 120, right? And that is obviously quite simple, right? That's in 120 ways, right? In 120 ways you can pick 1 out of 120. But there's a formula for that. So let's say if now the assignment changed to, well, generating monthly scenarios, based on randomly picking up from the last 120 months, is not really going to help me much, because I have a sample space of 120 only. That's not a big sample space. When you want to do bootstrapping, you're doing sampling, you need a big sample space to sample from, right? So the first step in bootstrapping is to generate a big sample space for yourself. So then you have to think, well, with 120 months of data, when I have monthly data, generating monthly scenarios is not really, I don't have much of an option, right? I can generate 120 scenarios by just repeating the past. If you told me, generate only 10 scenarios, all right, then I have some variations. I can randomly pick 10, and then I can repeat that experience sometimes to generate some different scenario trees. But the sample space is not big. But if I change then the problem from generating 250 monthly scenarios to 250 quarterly scenarios, where a quarter is made up of 3 randomly chosen months. So I'm going to kind of bootstrap a future quarter based on 3 randomly picked months of the last 120 months. So that's where the bootstrapping comes in. Bootstrapping is about coming with something which does not really exist in the real data. So I'm generating a quarter which has not been observed before. I'm randomly generating future quarters. Yeah.
Is it like 3 months, following 3 months?
No, it's randomly picked, right? So the idea with that would be if I have, let's say, these are the last 120 months, right? So I just randomly pick this one and this one and this one. I have those 3 returns, 3 months, and out of that I generate 1 quarter, right?
Is that realistic to do? Because I mean, often quarters are pretty linked to each other in a way.
Yes. So that's now you're getting more advanced. Yeah. So it's a very good question, and it's in and there are so the question, of course, have been asked before. So then you have to go to the next step of bootstrapping. Rather than using the simple bootstrap as I'm doing now, to begin with, you can use something called block bootstrapping. And the block bootstrapping would be like, well, if I pick this one, then I can just as well take this whole block, the next 3 months. Or I can say, well, then the next sample has to be somewhere around this area. So I want to get kind of those interactions of data, those autocorrelations into the picture. But in order to do that, if you want to do this properly, then you have to actually do an autocorrelation test in order first to convince yourself that there is indeed quarterly or monthly autocorrelations. Many times autocorrelations are seen on daily data, but not necessarily even on weekly data. So if that's not the case, if there is no autocorrelation, actually maybe it's better not to use block bootstrapping of any kind, just randomly pick. And so it's, but if you go down to daily, then you probably have to be careful about those effects. Right, but where we are now, so the question is merely, I want to have a bigger sample to pick from. And if I look into in how many ways I can pick 3 months out of 120 months, the answer for that is that binomial coefficient, which is 120 choose 3, which gives 280,840. And you remember the formula for that, how you calculate that thing? You can look it up on Wikipedia, but it's got something to do with the factorials, right? So that you have the 120 factorials divided by 3 factorials multiplied by, I think it's 120 minus 3 factorials, something like that. But doesn't matter. You can also there's in Excel you can also calculate this. I actually give you an assignment also to play with that. I think in Excel it's either called combin or bincom or something like that, and it's a formula in Excel. So you can 2 factors. You can write 120 and 3, and you will get that number as well. 280,840 is the answer. So you don't need to implement the factorial function. Right. So that's quite a lot, right? So that's quite a bit more than 120 still. Well, I mean, we can, many times, really, I want to see astronomical numbers, when it comes to sampling, right? So if you can play with that, then I say if you wanted to generate half-yearly scenarios, then it would be, 120 choose 6. And that would be a much larger number. Or yearly scenarios, 120 choose 10 or 12. That would be an astronomical number, a much bigger number, right? So then you can bootstrap as many years or as many half years as there are probably atoms on the planet or something to that effect, right? If you went to probably not with 120 divided by, or not divided by 120 choose 12, but then if you had maybe 20 years of data, or let's say if you go to weekly data, 10 years of weekly data, then then you are not generating, let's say, out of 120 weeks, but if that was 120 times, that's 10 times 52, that's 520 weeks for 10 years, right? And then you are picking 52 randomly from that. That number would be astronomically huge, right? So that you get the idea. You have to do this thinking before you start bootstrapping. Is my kind of sample universe big enough to begin with before I start sampling, right? And the question here is that I want you to pick 250. I want you to generate 250 quarterly scenarios out of a sample space of 280,000 something, right? So that's that's kind of reasonable enough. So the chances that you're going to repeat the same quarterly scenario twice or 3 times is very, very slim. It might happen, but it's almost not there, right? So that's kind of the underlying thinking. Now actually comes the actual bootstrapping. So we decide now that we want to do quarterly scenarios rather than monthly. And we just then get started. So to generate the first scenarios, and then you can generate all of them. So generating one scenario is simply randomly using a uniform distribution. So that the uniform distribution is that there is, if you have 120 months, you know, there's the chance of 1 over 120, you will pick any one of these 120. Randomly pick one number between 1 and 120. Do that 3 times, so you get 3 numbers. Get 6, 54, and 27. And those 3 months, then you combine them together to give you a scenario, a quarterly scenario. Then you repeat this experiment of picking up 3 numbers 250 times. Each time you generate 1 quarter, you have 250 scenarios of a quarter each. Does it make sense? Simple? At least as far as understanding is concerned, hopefully simple. Getting it to work, a bit more work, but then you're going to work with that. So I gave you an assignment to actually do that. So the assignment is about going back to the value at risk and conditional value at risk from last week, where you had in your input data, you had 154 months. So now the question is quite similar to that. So I want you again to do 250 quarterly scenarios. So I want you first to calculate that number, how big is your sample size, and then let's actually get to doing it. So generate 3 randomly generated numbers, and then out of that make a quarter, repeat 250 times, and then run it on the value at risk and conditional value at risk model. So that means also that you have to be able to use that model with different inputs, right? Good. We'll get back to that once you have questions, once you get to the exercises. Now, I want to wrap up with also a couple of slides which tell you something about how do you actually do some kind of quality assurance on the scenarios that you generate. And it doesn't necessarily have to do with the if you are bootstrapping, or if you're doing moment matching, or if you're using some other stochastic process to do sampling from. No matter what method you use for scenario generation, you have to have some of these ideas in mind in terms of testing the quality of your scenarios. Right, so the first thing to keep in mind is that the goal of scenario optimization is to find a good approximation to the true optimal solution rather than finding the true distribution of uncertainty. So what does that mean? Again, it goes back to let's assume that there is actually a what I call a true optimal solution out there, right? So we are in the search of the true optimal solution. It's an uncertain world, right? So it's not about capturing the uncertainty perfectly, but it's about knowing that the world is uncertain. In this case, we know that, well, the stock markets, we can't predict them. That's number one. But we can generate some scenarios on them. There is no such thing necessarily as perfect scenario sets. So we are not in the search of the true distribution of uncertainty. That's not necessarily, even if we get there, it's not really what we're looking for. We want to use that in order to make some decisions which are as good as possible. So if you can make very good decisions based on very rough data, you're still doing a good job, right? So it's important to know what you're really looking for. Focus on that. What you want to really test is that the results of your optimization model are going to perform well. So that's what you're really testing, and not so much the precision of your underlying uncertainty model, right? So that's point number one. And in order to do that, you can perform what's called, both in the sample. You have to do both in the sample and out of sample stability tests. And you can do some back tests, and preferably you do your back test over long periods of times, and we're going to look into all of those different kinds of tests in the following slide. So what is the in the sample stability test first? Well, in the sample stability test says that different runs of a scenario generator should give about the same result, right? So what does that mean? That means that in your case here, you can run this model once, you can generate 250 scenarios, right? And then you can run your value at risk and conditional value at risk models on that. And then you can go back and you can generate randomly 250 scenarios again, right? And well, I mean, and then there are two ways. In GAMS, essentially, you can either start with some for your random generation machine. You can either start with the same seed, in which case you will always get the same kind of uncertainty. It's kind of pseudo uncertainty, quasi uncertainty, as it's called, quasi sampling. Or you can start with a different seed, and then you can get different sets of uncertainty. So if you wanted to do this in the sample stability test, then obviously at each run of your bootstrap method, you have to start with a different seed, so you would get 250 slightly different scenario sets, right? You get different kinds of randomness introduced each time. But the question is, your scenario generation method and your optimization would be stable if no matter how many times you rerun your scenario generation method, you more or less get the same results at the end of the day. So that if you would do that, and each time you run your value at risk model, conditional value at risk model, they would give different results based on whether either you use one seed or another seed for your random generator, then your model is not stable, right? So even in the sample, your model is not stable. You have to do something with it. Probably you have to either add the number of scenarios, or there is something inherent in the nature of the uncertainty. Your model is too sensitive to small changes of input data, right? So that's called in the sample stability. That's one test that you could easily do. Today I haven't asked you to actually do that, but I mean you're welcome to if you're quickly done, or maybe sometime next week you want to get there. I'll show you how you can change the seed in your random generation routine, and then you can do this in the sample stability test. Right, so small changes in scenario sets should not result in big changes in the objective value of your optimization model, and solutions may be very different. That's something to remember, but the objective values should be very close. So what does that mean? So it could be actually that if the purpose of your optimization model is minimizing conditional value at risk, right? So it could be that you get, your conditional value at risk could be, let's say, a 3% loss or a 4% loss. So no matter what scenarios I use, what I'm interested in is that, I'll stay between those 3 and 4%, right? So that I don't expect that to all of a sudden jump to 10% to minus 1% or whatever it is, right? So I want the value of CVAR, if that's what I'm optimizing, that one to be stable. But it could be that the combination of assets which bring me there would be different, because there are many combinations of portfolios which give more or less the same results. That could happen many times in optimization. So that, if you see that, you don't have to kind of panic and say, well, my model is not stable. As far as the objective function is stable, that could be good enough. Many portfolios might end in the same result. So those are some words about in the sample stability. Once you're sure that your scenario generation is stable in the sample, then the next testing would be out of sample stability. So out of sample stability is about making sure that actually your scenario generation, your optimization model works in real life. So how do we test that? There are a couple of ways of going about that. One way is by using a very large scenario set generated with an exogenous scenario generator as a proxy for the true distribution. So what does that mean? In many cases, actually, it's a good idea to have more than one scenario generator. So you have one scenario generator that you use for doing your optimization. You might then use another scenario generator, which is somewhat similar, but with some different, different methodology, different factors. You use that to test. You use a bigger and more complete, let's say, scenario generation model and generate thousands and thousands of scenarios. You use that as you generate a scenario tree. You can call it the tree of truth. And then you can see, well, then I have another model to generate scenarios, fewer number of scenarios, use that for my optimization, and then I use the results, the optimal results which come out of my optimization models in the tree of truth, if you like, the bigger model that you're testing the stability of your results for, and find out whether or not your results would still be the same. So how does this work? So let's say I generate, just to make it simple, with this, I generate a number of scenarios. This one's not work. So just to make it very simple, I generate 4 scenarios. That's my scenario tree 1 to use for optimization. And that gives me an objective value in my optimization model. Let's say this is 12. All right, so 12 is somewhat, I have to test. What does this 12 mean? Is this 12 is a good number? Is it a realistic number? What is it? Then what you can do is that you can have this tree of truth. Say, well, this is one scenario tree. You can have another scenario tree. This is what I call the tree of truth. That comes from a different method. It could simply be, let's say, a number of scenarios, a number more. Could come also from a different method, right? So that's another scenario tree, normally more, it's kind of more bushy scenario tree, right? And now I say, well, in order to get this, I have an X star, which is my optimal solution. So with this optimal solution, in the tree that I use for optimization purposes, I get an objective value of 12, right? Now, if I place this X, if I place it into this tree, so X bar is now the input into this tree, and what I get out of that is my objective value in the tree of truth, right? So my objective value. So if this one is 12.1 or 11.9, then I'm happy. If this result was, I don't know, minus 100, just to come with an extreme example, then there's something wrong. So you see that point? That's another way of testing. That's out of sample testing already, because I'm not testing in the sample, not using the same method to generate scenarios and test my optimization again. Now I am actually fixing the results, and I want to implement it. I'm not going and implementing in the real world just yet the result, because what is X? X could be the portfolio you have to buy. Rather than going in the financial markets and actually put money into this, before that, you can simulate one more time by generating just a different kind of scenario tree and see what is the impact of that portfolio on an alternative scenario tree. And if the result there is close, all right, then you have some more confidence. So if your model was in the sample stable, so no matter how many of these ones you generate, you still get numbers close to 12. And the next step out of sample, you go and even fix that result in a bigger tree, different kind of tree, and still get the same results. Then it's the second check. Then you can be more confident in what you're doing, right? So these are kind of steps that you have to take before actually going live with the results of your models. And some notes to remember, it's when you're looking into a tree like this, make sure that you're including some extreme scenarios. So here in the tree that you're using for optimization purposes, it might be limited. You might not have so many extreme scenarios, but here you want to have some extreme scenarios included.
What could be an example of
An
an extreme example here?
extreme event? So an extreme event could be simply that, let's say, a drop in a drop in the stock markets that you haven't observed before, but you can anticipate that. Of course, it doesn't have to be completely out of proportions, but it has to be, well, can we imagine, let's say here, the worst scenario that has happened within the next 3 months could be a drop of, let's say, 20%. Here you might want to have a drop of, I don't know, 40% on the stock market. So that's, you want to go even further than what you had in your original set. And you can calculate the impacts of the implementing the optimal strategy on the new scenario set. That's exactly what I showed here. So putting x star into that one and recalculating the objective function. You could also, every once in a while, you want to even re-optimize in the new scenario set if possible. So if, many times you accept a smaller scenario tree because of computational reasons. So if you want to run this model every day, and let's say you only have 10 minutes in your disposal or half an hour in disposal for practical reasons, you want to maybe limit the number of these scenarios to some hundreds or thousands of scenarios. But then here you can have maybe a scenario tree that you only use once in a while for testing purposes, and this one can have maybe hundreds of thousands of scenarios or even millions of scenarios. And you can't run that every day. You can't run that every night, but you can maybe run it once a month or once every 3 months or so, and it can run for a week in order to find out whether now, while you are making some strategic decisions, let's re-optimize on this and actually see if the results still would be similar to the simpler model. So in that, these are kind of a stress testing your scenario generation methods and your optimization methods using scenarios. Right? And then there is one specific case of out-of-sample testing, which is quite appealing to people. It's called backtesting. And the reason why it's appealing is that it's actually, it's an experiment that is easily understood. This one is, it's quite interesting, actually, way of testing your scenarios still. Not many people would think of this kind of tree of truth testings as a way of testing your scenario optimization methods. But in many cases, you probably have heard about backtesting. Backtesting is about going back in time and pretending that you don't know the future. You just know the past from that point, and then you want to see if you want to repeatedly run your model from some time in the past to now, or some other further time further time in the future compared to your starting point, and then you want to see how your model is doing, right? So this is the process of testing a strategy on prior time periods in order to gauge its effectiveness. You go back in time, and you want to start running your model, and then after the fact, every time, let's say if you come 1 quarter forward, then actually you have the data, you know exactly what happened. You go and calculate the impact of what actually happened. So in that regard, there are 2 terms which are important to know. It's called ex post and ex ante. So anybody maybe has heard about those terms before? I want to say what that means. What is ex post? Yes, and what is ex ante? Before, right? So that's a kind of so that's and if you know post and ante, that's just from Latin, right? But that so ante means before and post means after, right? So but how do we use that? So let's say just we go back in time. Let's say we go back in use this one. Back in, let's say, 2008, in the beginning of 2008, and now it's 2018, right? So what we could do is, and let's say we have data which go all the way back to 2005. So I could use these 3 years of data. So I could use 3 years of data for training my model, training data. And I want to use this whole thing, 10 years of data for testing. This is my testing data. Right? And then let's say based on these 3 years of data, I generate some scenarios here. So I generate some scenarios. Right? So when I'm looking into these scenarios and I want to find out what I want to do here, what I'm doing, is it ex post or is it ex ante? It's before the future, right? So I do something which is ex ante here, right? Ex ante, so based on scenarios. So when I'm optimizing based on some future scenarios, I'm coming up with an ex ante strategy. Ex ante means before the future happens, what's the strategy? Now, after 1 month is gone, let's say 1 month is gone, and I know exactly this is what happened after 1 month. see if I have one more clear. Use just a blue one maybe. It's better. So let's say this is actually what happened. So the black scenarios were my scenarios based on which I get my ex ante result. Then I know that after 1 month this was the result. Then here is my ex post result. So based on whatever x star I get in here, I get a result which I know exactly that's what happened. That's my ex post result. That's how you do a back test, right? So by changing between ex ante and ex post and just moving forward, and then I can move 1 month forward, generate scenarios again, get the next ex ante result, and then from then wait until see what happened the month after that, look into my ex post result, and the combination of my ex post results would be the result of my back tests, right? So that's how a back test takes place. So back testing assumes that what happened in the past will happen in the future, and this assumption can cause potential risks for the strategy. So that's kind of a disclaimer that you should always have when you do back testing, and that's the kind of disclaimer that you will always get also from, if you're looking into the results of, back testings that you see for different strategies at different banks or investment funds and what have you. Obviously, the longer the testing period, the better, the more you can trust your results. But still, it's not, in general, you can't be sure that even though you get a very good backtesting result, that this is what's going to happen in the future. So there are kind of 3 steps again to remember. First, you have to make sure that your scenarios are stable in the sample. If they're not, discard them. If they are stable in the sample, then you want to do out-of-sample testing, this kind of tree of truth testings. Then you say, well, there is some out-of-sample stability, and you always want to spice it at the end by doing some proper back testing. And if you are actually doing fine through all the 3 processes, in the sample, out-of-sample, back testing, you're getting good results, then you might want to actually try them in real life, right? So the thing is, but be aware that even if you get very good results in all these 3 tests, it doesn't necessarily mean that you're going to get good results in the future, right? You can maybe think of it differently. In many cases, if you're not really getting good results while you're testing your scenarios, then that's a sign of either there's something wrong with your model or with your implementation. In many cases, it's very good in terms of debugging. Not so much the code. Your code will still be working, but it's more about debugging your logic. It could be the logic of your models, or it could be the underlying logic of what your thinking was about in terms of doing this model, right? So that's normally how you will debug your stochastic programming models. Right? Any questions? If not, I'm sure you're going to have some when you get into working with bootstrapping. So we take some break, and after break, we'll go to 2 exercises, or first evaluation and then exercises. All right?